In the recent video about a generator changeover switch, I used these indicator lights, generic EB indicator lights, just to show the two channels, effectively the two modes it was in, the generator or main power. And a few of you asked about the indicator lights, so let's take a look at them. They're LED based, and I have a feeling maybe it was these that gave me the nip while I was connecting them to the thing. I'm just going to be very careful here because pretty sure you can usually tell if these things have a charge in them. Sometimes it makes the LED blink, you short them. Yep, the LED blinked, so these things are holding charge. They're not consumer friendly. Yep, that one flashed as well. Okay, so this incidentally, before MD asks, it's a Cliff quick tester. It's used in workshops for making quick connections to flexes and cables. Very handy device. Also available in American and Canadian colours. There is someone selling them. I can never remember. I mentioned them in another post. There is a video about the quick test. So these indicators, I got them from an eBay seller called Reselling 2012. So that's Reselling 2012, and they've got a huge range of these indicators. And I also bought these ones thinking they were probably going to be LED, but it turns out they're not. They're 240 volt, but they've actually got the small screw-in neon indicator lamp with a small neon inside the outer plasticky envelope and the resistor. With these tiny indicators, I tend to recommend that they're quite, shall we say, ungenerous with the resistor value in there. They tend to run them quite hot just to get maximum intensity. If you don't need maximum intensity, I recommend adding an external resistor as well, just to prolong the life. But the white, orange and red ones have an orange neon indicator, the clear glass one, and the green and blue ones have the little white phosphor dusted lamp inside them. Quite nice. You may notice I've got a bag of them. It's because it's one of those listings that if you order one, it's only about 20 pence more for two of them, so you might as well just, get two. And I have spares. Particularly given that, the actual neon indicator lamps would cost more from British suppliers. That's quite annoying in a way. The green and blue, as I say, they've got the green phosphor neon inside, so maybe not ideal for the blue, and it's going to be quite dull because those tend to be quite low intensity indicators. But having said that, these take a standard, I think it's an MES lamp, M10, E10. So they will, you can put different lamps in them. You could put tungsten, I suppose, or LED ones, or just use the neon ones. However, these are not the main subject of the video. These are the main subject of the video. They're very chunky, they're very neat. Let's take one to bits. So this unscrews. Now I was originally thinking maybe the lamp could be changed in some way, but I think this really is a fully assembled unit. So let's find an alternative way in. Let's start by whipping the wires out. Now it's discharged. No tingles this time. And we'll take these screws out here, which seem to hold it together in a sandwich of pieces. So it's got two screws and two nuts, which I've just popped off. And that reveals the connections, which just lift out. That's very similar to the construction. Oh, that's very similar to the construction of some of the other ones. I wasn't expecting this bit to pop out quite so easily. So what have we got here? We have a resistor, brown, red, red. That's 1, 2 and 2 zeros, 1.2K. And we have a capacitor, which it's rated 630 volts. That's good, because some of the other ones were rated quite low. And it's 100 nanofarads, so it's very low current. So the LEDs, there's either some rectification going on inside, or they may just have done what they did in some of the others, and they used the LEDs in sort of parallel, reverse parallel arrays. So let's test this and see what voltage it operates at. If I bring in this resistor array and set it for 1K, and it won't really matter the polarity, and we'll bring in the bench power supply, which I shall turn on here. And I'll set it for about... I'll set it down quite low initially to about 7 volts. And I'll put that in line. And the LED is actually lit up already. So let's turn this up till it gets about 10 milliamps. Okay, so 10 milliamps is about 14 volts. Okay. And let's measure the voltage across the LEDs. So if I measure the voltage across that now, it's about 4 volts, 3.93. So that suggests 2 red chips in series, and there'll be, if I swap the polarity, it should also light. I wonder if there'll be a visible pattern change. It's not. It's so diffused that you don't see a pattern change. Some of the others, you could expose the LED circuit board and you saw different LEDs light up. So I'm going to make a guess here. I'm going to make a guess at the circuitry in here as being very, very simple. Where's my notepad? Test started at 7 AM. That was my little mains powered emergency light. Which I started the test at 7 AM in the morning, and it was still lit about 10 hours later. Not the same brightness, but still amply lit. So onto the subject of this, we've got the mains coming in. There's the mains coming in through a capacitor with no discharge resistor. It's a 100 nanofarad, 630 volts, which is good. Some of the other LED lamps had only got 250 volt capacitors, which I felt was a bit low, but it's nice to see a generously rated one, a very generously rated one. And it's got the inrush limiter of 1.2 kilo ohms. And I would guess that inside is probably 2 diodes in series like that. It's the cheapest way to do it. And 2 diodes in series like that. And there's a very good chance they've just bridged that to there as well, so that the reverse voltage across any diode, even with one of them leaking, can't exceed the voltage across the other one. So it caps it to less than 5 volts, which is what's really needed for those LEDs. So that's super simple. That's very nice, actually. It means that the indicator, if the LEDs fail, which the red one's much less likely to do that, the green gallium nitride technology may pose a higher risk of getting dimmer or flickering or failing. But the red one will be super reliable, I should think, particularly with such a simple and straightforward circuitry. The low value capacitor and that fairly generous resistor that's going to limit the maximum peak current even when first connected or when there's spikes or transients to about 250 milliamps, which will be well within the spike handling capability of the LEDs. The other option here, if you wanted this to be low voltage, is just to put a resistor in here and get rid of the capacitor. So you could hack these to operate for about, well, from about 5 volts upwards with the red LEDs, probably about 6 volts upwards for the green LED, because of the slightly higher forward voltage. But that's very simple. It's very neat. I'm guessing that's what's inside, but it almost certainly is based on previous units. And they're very nice lights, and the range is just staggering. I'll put a link down below to this seller because they've got a really massive range of the indicator lights. It's very, very good compared to, I can recall when I was younger for projects buying things like this, and they were really expensive when I was young. But now they're so cheap from China that, you know, they're great for projects and stuff like that.